Okay. Okay. In the previous class, first of all, do you have any questions with regards to the previous class or lecture? Okay. If you have anything, you can leave it to the end of the lecture. Today, inshallah, what I'll do, my plan to finish the CT performance at steady state operation, and also I'd like to cover the transient CT performance. So in the previous class, I have covered the how do you select or check the CT class according to IEC IEEE standard. Okay, and today, inshallah, I will try to show you how we select CT based on their IEC classification, and I'll give you an examples also. In IEC, they specify CT class with this number, a letter, then a number. Okay. So what does this? And normally, before these two, the class, you have also the rated burden in volt ampere. So this is the rated volt ampere of the CT, and what comes B for protection, and or M for measurements. While in IEC, in the IEEE, it is either C or T. Okay. Uh, Now the number before the P, the letter, which is 10 in this case, it is the accuracy class, which is the maximum composite error. Maximum error here now in 10%. So this error, according to IEC, it could be 10 or 5. So we have two things. While in IEEE, this is only 10% defined in IEEE. The maximum error is 10%, where in IEC, they define either can have 5B or 10B, 10% error or 5% error. And this number, following the letter, which is green now, 20, this is the accuracy limit factor. In IEEE, the accuracy limit factor was 20 fixed, okay? While here in IEC, they have specified this number as it could be 5 or 10, 15, 20, or 30. So they have more flexibility in classifying, wider range of classifying CTs based on this. And as I mentioned before, what does that mean for this CT? Means if you put a burden of 15 volt ampere at the secondary of this CT as a load, and the current at the secondary or in the load is 20 times the rated current, which is in this case 5 or 1, okay, then the error will not exceed 10%. That's what it means. Okay. So there is a similarity now between, if you would say, what is the similarities between or the equivalence between IEC class CTs and IEEE class CTs. So in the IEEE, they classified the voltage class like C400. Okay, in this case C400. This is the voltage class. What was the error? 10%, which is not, because it's only one thing. And this is this voltage defined at the rated burden of 4 ohm at 20 times rated secondary current, which is 20 times 5. And this is the maximum voltage at the burden. Now, to make this, what's the equivalent now between these two, or so the accuracy limit factor, if you multiply it by, let me check this one. Yeah, so And the voltage here, voltage at the burden, which will be the voltage class is the voltage at the burden is I secondary nominal, okay, maximum, which is defined as okay, I secondary maximum, which is 20 times according to IEEE, okay, times the burden, R burden, okay. That gives you the voltage, okay, voltage class. And this defined as 20 times 20 times I secondary nominal. And this was 5 ampere, the nominal in according to IEEE. And the burden, of course, this is at the nominal burden. Now we can convert burden in volt ampere by, if you take the burden, is also can be given in volt ampere by taking the S burden nominal. Of course, this is nominal also, nominal burden, which is, we said, either 1, 4, or 8, either 1, 2, or 4 or 8 according to IEEE standard burden over I secondary nominal, which is 5 also squared. Now if you take this with this squared with 1, I get 20, okay, which is 20 times the S burden nominal divided by the I secondary, which is 5 ampere in IEEE. And this 20 represent the accuracy limit factor according to, if we define it, okay, by IEEE. But by IEC, it is called accuracy limit factor, which is only one number in IEEE, 20 times. Okay, so it is, we can now, if I have IEC standard accuracy limit factors 20 or 5, they define 20 or 5 or 15, 20 or 30 times, okay, in this case, times the volt ampere rated, the rated burden of the CT divided by, which is given here, this is the rated burden over the CT in volt ampere, this is the accuracy class of the CT over the rated secondary current, okay, gives me, which is I normally rated, I put nominal in. That gives me the voltage class at the burden according to IEEE, which is the 400 or 100 or these the 4 classes I mentioned here. And according to the 4 classes, okay. The C1 400, C100, C200, C400, C800. Okay, and the burden, which is standard burden in ohm, as I mentioned, it is S burden nominal over I rated secondary square. Give me R burden, or here I put it here Z burden or R burden. Now, if I have, for example, this CT, 30 volt ampere, and for IEEE also, the burden, standard burden in volt ampere is 2.5, 5, 10, 15, and 30. This is the standard burden. And while in IEEE it is 1 ohm, 2 ohm, 4 ohm, and 8 ohm are the standard burden in IEEE standards. Now, suppose I have this. What would be the equivalent a class, CT class, equivalent to this with respect to IEEE or ANSI? Okay. So what we'll do the same thing, right? Now, what does this mean? The current will be 30 times, okay? The current here is 30 times, and the burden here 30 volt ampere. So I have to see what would be equivalent voltage, and the rated current here is 5 ampere. So I'll check the voltage. So I have 30 times rated secondary 5, okay? And this is the error. This means the error is 10% error. This is the error, 10% error, which is also defined in IEEE standard. So 30 times 5, which is now the maximum current. 30, this is the accuracy limit factor, times the rated secondary current, which is 5. That gives me the maximum current, times the burden. According here, I'll just need to have the volt ampere over, or I multiply it by the burden. So volt ampere rated over I secondary, which is volt ampere rating is 30 divided by I secondary 5. Okay. Now, so in this, so it's already, I don't have to, because this is 5 square. Because in this formula, I already cancelled this with this. Okay. So it is like 30 times accuracy limit factor 30 times 30 over 5. So I already this would cancel with this. This is, I'm using the actual here, but I can use this one formula. Okay. So in this case, I get 30 over 5. Okay, which is 6. 6 times 30. Okay, so 180. Okay, volt. Right. So this is and let me check. It's right, isn't it? This is 6. 6 times 3, 18. Okay, so it's 180. So 180 volts, so this is equivalent to, okay, 200 volt. And that means this is a C200. C200. Okay. Because in C class we have, in IEEE you have C100, C200, C4. This one. Now let's take a practical problem that covers what a realistic problem. Now I have here, I have a CT that I want to select. Okay, I want to check if it's if it is suitable or not, if it is adequate or not. Okay, the CT given, the CT ratio is this, and CT secondary resistance, this is the CT resistance RS. This is RS according to equivalent circuit, and the relay which is connected to that CT is 0.02 ohm resistance, and the lead resistance is 0.15 ohm. The CT class is 10B20, and the burden, the rated burden is 7.5 volt ampere. Check if the CT class is suitable for the overcurrent phase and ground relays. Okay, so how is this is connected, and this is the maximum fault that the CT would, this is the maximum fault at the CT location. So to imagine how an overcurrent relay overcurrent phase and ground over. This is the inshallah we have one chapter on this. So these are the three phases A, B, C, and this is the feeder, this is the bus bar, and this is the feeder that goes to maybe one load here. And this is the circuit breaker, and I want to check, I would like to provide a protection for overcurrent protection by using relays. So these relays will be fed. Now I have 4 relays here. 50 represent an overcurrent, which is instantaneous, and 51 represent an overcurrent but time delayed. We'll come to this inshallah later. So the CT in each phase, phase A and phase B and phase C. Okay, phase C. So this is phase A, CT, phase B, CT, phase C. You connected to star. Each phase goes to one relay here. Second phase go to the second relay. Third phase goes to the third relay. And the output of each relay are connected to us as a star point, which is at these 2 points. And the star points is connected to the ground over current relay. Okay, and this goes back to the star points. So this is called the this is the ground over the ground over current relay, and these are the phase over current relay. So these are 3 reference phase. Okay, over current or CLC relays. And this represent, okay, the ground over current relays. And this ground over relay is to detect ground faults. Any fault, phase to ground, or B to ground, C to ground, will be a current passing in this relay. If this current higher than the pickup setting, it will operate to trip the circuit breaker. While these trying to protect the circuit against 3-phase faults or face-to-face faults. Okay, so the current here that will pass here is the neutral current or the ground current, which is the 3 times the 0 sequence current. Now this is, to draw this is the schematic diagram, okay, the equivalent circuits. So the equivalent circuit, this is the line A, B, and this is C, which is this represent this 1, 2, 3. And secondary side, I will now draw the draw a resistance of the secondary, the CT resistance. This is RCT, which is before I called it RS in the equivalent circuit. So what I'm drawing here, and this one. So this is, we call it RCT. Okay. Now this is negligible. Okay, this is the CT. Now this is the secondary terminals of the CT, which represent now this point. Now I have a resistance that represents the wire that connect the CT to the relay, which is R lead, and I have a resistance that represents the relay itself, RR. And I have a star point. This is for second phase, and this is for the third phase. And I have a then I have a star point, which is this, the star point, which is this point now. It goes to a fourth relay, which is this for the earth. This is for the ground relay. And then I have a lead resistance for the return back. This is the lead resistance from here to here. And all these 3 CTs are grounded as a star. So this is the star point of the 3 CTs, secondary side. So this is the equivalent circuit of the uh, three-phase, okay, of the phase and ground over current relay connections. Now I'm assuming the lengths are here and here, or approximately the same. So these lead resistance are equal, okay, and it's given. RCT is given 0.26. RR relay also given. I'll assuming also RR for the ground is, but it's not necessary for overcurrent relay. Sometimes this is different than this. But in this example, I'm assuming it is same. Okay. So this also of the ground is 0.02. Now, in case of now, what I want to see, the burden of this CT, the nominal burden is 7.5 volt ampere, is the maximum error 10%. It is protection class CT, and accuracy limit factor is 20. And this is the CT ratio 1000 to 5. Now, is this CT suitable for this or not? Okay. Now, what I have to do, I have to check first the burden. Is this burden is sufficient, is correctly suitable for this application? So I have to check what is the actual burden, and this is the nominal burden. So this is the nominal. Rated burden, nominal or rated. Rated burden. Now I have to check the actual burden, which is the load now currently connected. So actual burden is this, which is represent the lead and the relay, and we don't consider here the ground. Okay, so we considered the phase relays, because during the burden normally is measured during normal operating conditions. During normal conditions, the sum of the current is the system is balanced, so the sum of the current is 0, so there is no current passing in here. So there will be no, this current will be 0. So there will be no burden of exist on the CT due to the ground over current relay. So now burden will be, I have to take the secondary current nominal at nominal times the burden. Now these are the R burden. Actual. So I have to check this one. So first of all, I have to check the burden requirement. The nominal, this is now nominal. Nominal. Nominal is the, what I want to check this into R, from S to R. So S over I secondary rated current is burden nominal over I secondary rated square, give me the burden nominal at an ohm. So this is 7.5 volt ampere divided by 525, I get 0.3 ohm. This is the resistance burden equivalent to 7.5 ohm. Now I have to check what is the resistance now, or I can convert this into volt ampere. I check with this same thing. So what is the burden, actual burden? So this is the actual or connected. It's very hard to write with a mouse. So this is the, I'll try to change my mouse. The other one maybe better. Now, this is the R relay burden plus the lead burden. If you add them, 0.15, 0.02, which is point. Okay. Now, is the burden suitable, Shabab? Can we check, is our burden 7.5 volt ampere is suitable for this application or not? Anyone can answer. Is it okay or not?
It's okay.
It's okay, good. Why? Because the actual burden, okay, is smaller, okay, because Rn, R burden nominal, is greater, okay, than R burden actual, okay, so it's okay, okay. So I'd say the burden is okay, which is means 7.5 volt ampere CT, okay, means 7.5 volt ampere burden CT is okay, or is sufficient. Suitable, okay. So this is my conclusion with respect to burden. Now this is regarding burden. Burden is measured at rated secondary current. So I can do also the same thing. I'll find this, I multiply it by IS square, which is 25. I'll check then with S 7.5. Okay, it's either way is fine. Now this is the first step. Now, second step, I would like, which is not required here, because all I'm checking the requirement. Also, I would like to check the, and so later I'll check also if this CT ratio is sufficient or not. But it's later in another application, inshallah, in the next chapter. And now I'll check the class. Is the class is suitable or and adequate or not? Now let's take, first of all, I'll vote, I'll say for three-phase faults. Okay. For the phase over relays, for the phase, I'll say for the phase over current relays. Now I'm checking the requirement is this is suitable for when I have this, okay, relay. Now this relay acts when you have symmetrical faults, like three-phase faults. So normally I check this at maximum secondary current. Now maximum second current will come when you have maximum faults. So maximum fault, and this is for a three-phase fault. Three-phase faults is the maximum. And for three-phase fault, when you have a three-phase here, short circuit here, so short circuit here, you have maximum current at the secondary. So also maximum current here. So what's the maximum current will be 7,226, which is here. So where is this? This is a fault now. I have, this is I fault maximum, which is here. The current now here in the primary will be maximum is 7,226. Now at that current, what will be the neutral current for a three-phase? This current will be zero at that situation. This, because this is still three-phase and it is symmetrical, so the summation of currents is zero. So what's during three-phase fault, this will not be considered. There is no current path here, so only the burden for each CT is this path. Okay, so what I need to find this voltage Vs, and we'll compare it with the voltage class. Okay, a voltage requirement. So what is this Vs? Actual is I secondary maximum times RCT plus RL plus RR without this one. Okay, because this current for this equal to 0. So this is what I'll say. The required voltage Vs at the secondary side of the CT at maximum short circuit, which is I secondary maximum, times the RCT plus R burden. If you will substitute this, what would be the answer is 7,226. This is I fault. I divided by CT ratio, which is 1000 over 5. That gives me the secondary current, right? And multiply by RCT, which is 0.26, 0.26 plus R burden, which is R burden, RR plus RL, which is 0.17. And the answer of this is it will be 15.54 volt. Okay, so this is the voltage that will develop at the secondary side of the CT at maximum fault current during. Okay, now I have to compare this with the voltage class. Now, does this CT class can handle this voltage without saturation, so that this, we don't want to exceed the 10% error. So what is the actual voltage class? So we say we define the voltage class here as the nominal accuracy factor. Now this is the voltage at the burden. Okay, but here this voltage, what I want to calculate at the secondary. So I will compare this with also the burden with the voltage, okay, according to the CT, that I should not exceed. So what is my maximum? The CT voltage class, the CT VK or voltage class is accuracy limit factor by, this is the accuracy limit factor nominal specified by the CT nominal, times rated secondary current, give me the maximum current at the secondary side according to the CT. The CT 20 times rated secondary current, which is 5, times RCT plus R burden nominal. So this is R burden, this is R burden nominal. Now R burden nominal in this CT is it's same as I did here, which is volt ampere over I secondary square, right? So it's burden nominal over I rated secondary. So I substitute here, accuracy limit factor was 20, this is the 20, times rated secondary current is 5, times, now if you multiply this by this, it gives me the voltage class with respect to the at the burden. It gives me voltage class at the burden here, this voltage. Okay, from here to here. But I want V secondary compare with V secondary. So RCT is 0.26 plus the R burden is 7.5. Sorry, S burden divided volt ampere over 25. And if you substitute this one, I'll get 56 volt. Now, well, is this now suitable or not with respect to three-phase fault? What do you think, guys? This is 15.5 is the actual VS that will develop at the secondary side of the CT at maximum fault current of 7,226, while this CT, okay, at its maximum specified accuracy limit factor and specified rated burden, the voltage that should develop is 56. Is this adequate or not? Is the voltage class 10B20 as adequate or not? أحد يجاوب.
No.
Why no? من معاي أول شيء هاي اللي دائما يشارك ويانا.
Yasin, because the voltage difference is too.
حسين.
Yasin.
ياسين تفضل ياسين.
Because the voltage difference is too big.
يعني ليش أنت قلت إنه was not adequate؟ أي هو الأهم؟ هذا حين والله ده؟ من هو الريفرنس مالنا حين؟
15 volt.
لا الريفرنس مالنا هو هذا. This is our maximum voltage. This is our reference. This is our rated. Okay, this is our rated values. Why is rated? I use rated accuracy limit factor specified by the CT20. I use the rated secondary current, a rated burden, which is here. So everything is rated. So this is what I should not exceed. This is my limit. But this is my limit in voltage. Okay. Now, this is the actual. This is the actual. Now here also, this is the limit, the burden limit rated. And this is the actual. Okay, so this is the actual. Okay, so because now, since VK, the voltage that will nominal voltage class is less than VS, sorry, greater than VS. So even if it is equal is fine, but here also even it's equal is fine, but shouldn't be smaller. Since V greater than VS, then the CT, therefore the CT, okay, CTVK voltage class is adequate. Okay. All right, guys, 56 greater than this. This is what I'll develop a voltage due to this burden of the relays and lead, and this is at maximum fault current. This is represent my I fault. maximum refer to the secondary side. Okay, now I can check also the
دكتور
yes,
الفولتج كلاس وين صايره في السيركت؟ لا فوق.
the voltage class is this. Okay,
اللي هو
voltage at the knee point. And تخيلون the knee point voltage is the voltage class of that. Okay, the voltage class here is this C400 in this case, which you should not limit. But in IEC, they don't specify the voltage. Okay, they specify a maximum limit factor and the rated burden, and you calculate the voltage class according to these two numbers. But I can compare the voltage at the knee point of that CT with respect, either I can compare at the burden the two voltages, my limit and what's actual, or at the secondary here. The advantage by comparing VS, the actual secondary voltage, with the voltage class, my limit at the secondary, that I even include the voltage drop at the CT. So that's more accurate as comparing CT, the voltage is just at the burden. Okay? All right. Any more questions? Now, what's next also here? And let's check also. Okay. Now, I would like also checking the voltage class. Also check now for me. Check the VK requirement. Okay. For air faults. Okay, so what I did here for phase, this is for three-phase fault. Now I'm considering three-phase fault. Now if I have a three-phase fault, means line to ground faults. So I have a fault something like this, one phase to ground. This is line to ground faults. Okay, so, or it could be A to ground faults or B to ground faults. Now at that situation, the current, of course, for line to ground fault will not be 7,226. This is the maximum fault. So if I know this, what was the minimum fault current for ground faults, then now let's assume the ground fault current, I fault to ground, I fault for line to ground, LG. Let's assume now. It is equal to, let's say, I will assume it is 10 times the rated secondary current of 5 ampere, let's say, or let's say, now I'll assume it is same as but this is a worst case scenario. What I'll do here is a worst case scenario. Okay, let's assume it is 2000, 7,226. But this is not won't be a possible case, 7,226 ampere. Okay, it will be much less than this. Now what can we check now? The burden, can we check VS that will develop? Okay, now I'll do the same thing. 7,226 divided by CT ratio, which is 1,000 over 55. Sorry, this is I fault referred to secondary side. Now RCT is 0.26. Now look to this, very important. What will be the current path for ground fault? Now for ground fault, suppose the fault is in phase C. It's here fault. And now this current will be normal current. So will be no fault currents here, only in phase C. So the current here will be here. This is I fault at the secondary. This goes here, goes here. Let's assume this current, fault current is much larger than full load current. This is like normal load current. So the fault current comes here, and this is the fault path. Okay, so this is the loop. So in that loop, the burden now, this Vs that you will calculate should include what? RCT1 plus 2RL plus 2RR, right? So in this case, to calculate for ground faults, I have to find now 2RR, which is 2 times this, so 2 times 0.17, so 2 times 0.17, which is 2RR plus 2RL. And that's equal, if you take, I didn't calculate this one, so that's 7,226 times 5 over 1,000 times 0.26 plus 2 times 0.17, that's 21.7 volt. And what's the actual voltage class? What is limit, voltage limit is the same thing we'll do, 7,226. Sorry, that's not right. The maximum current defined, the it is the accuracy limit factor, which is in this case is 20 times maximum sudden current, which is 5. This is accuracy limit factor nominal times the I rated secondary nominal. This is our maximum secondary current according to the ratings times the point, the 0.26 okay, so the 0.26 plus 2 times this, which is sorry, now the burden here, it should be the burden will be in this case the rated, rated, but still we are talking about rated, which is same as, which is should be same as 56, which is 7.5, because this is our limit, 7.5 over 25, which is also 56. Okay, So even now, I don't have to calculate, we have already done this, okay? So therefore, also Vs here, or Vk, greater than Vs, so it's also adequate. So, okay, so therefore Ct, if Ct is adequate, or I'll say suitable for this application. Okay, do you see this example? It's covered. I can also check the IEEE. I can give you the same problem with this is like C400, this 1000 to 5, and I want to check. So what does that, the voltage here is 21 points. What does that mean? Voltage is less than this. What does it physically mean? It means that the error, okay, will not exceed the 10%, which make it suitable, okay, appropriate. If I exceed this 10%, error means the error will be excessive in terms of ratio errors, okay, and as a result, it won't be suitable. It will be rejected in this case. This is the summary, okay. The second, yes.
بالنسبة للفولت باث دائما يكون ون فيز ولا شو اسمه يختلف؟
بالنسبة لشنو؟
الفولت باث حق الكرنت
فولت باك؟
ايه
يعني وش الفولت باك؟
فولت باث طريقة
الفولت باث، ايه اوكي.
ايه دائما يكون ون فيز ولا شو اسمه يختلف عادي؟
يختلف على نوع الفولت. لو كان فيس تو فيس فولت ني اوكي بيكون عندك فولت current في two phases. Assume there is no faults here, so this here normal current, load currents. So the fault current عادة very large current load, فأنا أفترض إن هاي كانها صفر with respect to fault current. In this case I have a current path like this will be. لو الفولت صاير بين الفيزين. Okay. And this is the fault path. But now, to consider VS, this VS, I have to, the VS across one phase. And الحين هذا الباث also will have, like the path is like this. We come here, this come current here, come here, okay? So come here, and come here, right? Returns here. And so this is the path, okay? So we have two VS here, VS here and this VS. So like to take also the voltage of one CT, voltage secondary, one V, because this path goes through two VS, right? So what is the voltage across one CT? This is symmetric up to from here to the star point, to that point. The same from here to this point through the other CT. So the VS here will be just this secondary current, which will respond to the fault current referred to secondary side, times RCT plus RL but RA. So for phase-to-phase faults, we'll do the same thing as we did for the three-phase fault. Okay? يعني this becomes just RR plus R lead. I will not take two times. So whether it's three-phase fault or phase-to-phase fault. But for ground faults, the ground fault path will include a return path, this one, okay? So that would become this 2RL and 2RR.
بس دكتور من فيس تو فيس ما بيكون في بعد اوريدي ار حتى الار سي تي المفروض تتبع له ولا ما له شغل؟ يعني الار ال والار ار مو المفروض كم ضرب اثنين؟
الحين لو ناخذ كي في ال هني خذوا كي في ال الحين بين هالباث.
اوكي.
بصير عندنا 2 في اس صح؟ و 2 RL و2 RR و2 RCTs صح لا؟
إيه. إيه.
يعني لو قسمنا على 2 بتصير الفي تساوي IS في RCT في RR في RL. أنا يهمني الحين الفي اس وحدة على 1 CT. واضح؟
إيه تمام. يعطيك العافية دكتور.
Okay. All right. Now, what's left now in the here is the هل أحد سطلتون لو الحين saturated your brain saturated like the CTs or not yet؟
دكتور.
ها؟
قريب يوصل ستادي ستيت دكتور.
قريب للني بوينت أو
خلاص
Steady
ما في
state.
الني بوينت.
أو طفتون الني بوينتس.
في الساتوريتد احنا.
Okay. I don't want to you know, although I will be tight then in time, but how do I compensate for this half 15 minutes of the lecture time? If we'll go like this, we'll not be able to cover the material. This is an issue. Because I have still the voltage transformers. This is the problem. I have also now to cover the voltage transformer to cover this chapter. So this needs at least 20 minutes. Right. So anyhow, I will stop at this point. But get prepared. I need to increase your knee point so that you don't saturate within 1 hour. Okay. So what I want you to do, increase your class. Okay. So how do you increase your class? You sleep very well. Okay. And you get and read the material ahead of time. So what I want you to do, read this one lecture, all right? Read this lecture, and I want you all to read, okay, this is as now my compensation. I want you to read this lecture, and I want you also to read the voltage transformer lecture, so that we can cope with this lecture, okay? So this is what I want to do in the next class, inshallah. I'll stop at this end. Do you have any more questions? أسئلة ثانية.
Doctor, what about the assignment one? When should we submit it?
Okay, assignment one already I covered, so I will give you also a week, يعني by next week, okay, you'll be able to. Already I specified in the blackboard, didn't I? Specified the date, due date. I think I specified in the blackboard the due date.
دكتور ما يوصلنا نوتيفيكيشن إذا تسوي جروب في الواتساب وتخبرنا قبل يعني. أنا ما أعتقد.
لا يعني انت الحين في الاساينمنت في البلاك بورد already when you download the assignment shows you this is due on this day and you have to upload the assignment in the blackboard so you know the due date. Okay, already I specify. I think by next week is the due date. But check the blackboard, please.
Okay, doctor. Thank you very much.
Okay. مع السلامة شباب. Any more questions? خصوص دلين اللي وصلوا saturations. I have ways to make them goes down below the saturation.
لا خلاص دكتور يعطيك العافية ما في
الله
شيء.
يعافيك. I will stop recording, okay?